I can connect the area model and the partial products method to the standard algorithm. Okay, time to get your brain thinking with a review. Go ahead and pause and solve these problems. Is it starting to move? Let's try another review here. I'm going to give you the multiplication sentence. I want you to tell me it in unit form. So if you look, I have 43 times 2. How many tens do I have? I have 4 tens. I have 3 ones, and I take that times 2. Write an equation for the area of each rectangle. Then find the sum of the two areas. Bonus, find a faster method for finding the area of the combined rectangles. Now remember the area, when you have area, you have the length times the width. Now they call this, let's see, this is the width. So my width is 8. My length of 1 is 30. Okay, so go ahead and pause, solve. Don't forget about this rectangle. And then find the sum. What's the word sum mean? Sum is the answer to an addition problem, so you're going to have to add these areas together once you're finished and find out what the area of both rectangles are and then what the combined area of the two rectangles are. Now there is a faster way to find the area of the combined rectangles. Why don't you pause and brainstorm and see if you can figure out a faster way than taking 30 times 8 plus 4 times 8. Can you find a faster way? Pause and see. Okay, how do I find the area of this rectangle? What is the area? Now, if you remember, you can pull the 100 out of this problem. Remember, like we did back, I think it was lesson 3, maybe? If you pull the 100 out, that leaves you with 8 times 2, then times 100. Do you remember that? So if I do 8 times 2, I have 16. And then how many zeros do I have in my 100? 2 zeros. Remember that? So the area of this rectangle is 1600 or 1600. Okay, it's length times width. So let's look back to the first problem where we had the two rectangles. They also had a length of 8. Let's combine all 3 rectangles. Now sometimes I get confused with between length and width. And if you think about it, when you say the word length, it's long. And when you say that, your jaw goes down. So you could say that this is the length, because when you say long, your mouth goes down. So when they talk about the length in Engage New York, they're talking about this side right here, okay? So they also had a length of 8. So let's go ahead and let's combine all 3 rectangles and see what we end up with. So here's our first 2 rectangles that we had to begin with, and here's our third one. How do we find the area of all 3 rectangles? All 3 rectangles. what do we do to find the area? Why don't you pause and talk about it? So we could add the length and then multiply by 8. So see, now they're calling this the length and then multiply by 8. So sometimes even I think they get confused with what they call it. As long as you can keep your numbers straight, length and width. So what they did was they took the 3 lengths, 200, 30, and 4, add them together, and then they're going to multiply. When you have a number right next to a parenthesis like that, that means to multiply. Okay, so you could add them and then multiply by 8, or we could multiply each length by 8 and then add the sums. What's the word sum mean again? Sum. Sum is the answer to an addition problem. So we could multiply each length by 8 and then add the sums. So maybe we should write this down. 8 times 200 plus 8 times 30 plus 8 times 4. Now, back when I was teaching, we used to do something similar to this, and we called this distributive property. And maybe once we get a little further into these lessons, they'll start talking about what that means. So for right now, we're going to look at this as 200 times 8, 30 times 8, 4 times 8, and then add each sum together. So, which one would work the best? You're saying to multiply each section of the width times 8. So, 200 plus 30 plus 4 times 8. So if we have 200 plus 30 plus 4, we end up with 234. 234 times 8? 1,600. That's not right. 200 times 8 is 1,600. It's a little typo there I need to fix. Okay. Now I see what they're doing. Okay, so now you're going to find the area of the green rectangle. Remember when we did the partial algorithms where we added each area? That's what they're doing now. So 240 would be the answer for the next rectangle, the green rectangle. So 30 times 8 is 240. Because 3 times 8 is 24, and then you add a 0, 240. Now we'll find the area of the yellow rectangle. 4 times 8 is 32, so we're going to add that. So basically what they're doing is they're taking the area, or the area of each rectangle, and then they're going to add it together. And that gives me 1,872. We call this right here an area model. Okay, area model. How many hundreds, tens, and ones are in 316? Go ahead, pause and discuss. So I have 3 hundreds, 1 10, and then 6 ones. So now you're going to try it out. You're going to draw an area model with a width of 3 hundreds, 1 10 and 6 ones, and a length of 4. So go ahead, pause, draw it, and see what you get. So if you look, let me rewind here. I'm going to go back. I'll draw it for you so you can see how that looks when I draw it. So I'm going to start with 300. And what's my length? My length is 4. And then I'm going to do 110. Do I need to add a length again? Nope, I already have it. And then I'm going to do 6 ones. Okay, so that's how yours should look. Probably a little fancier than mine. Okay, I didn't go to school for art, so you just have to live with it, I guess. So check it out. Does yours look like that? Okay, so if you see, this whole thing equals 316. Let me change my color. Now let's multiply 4 times 3, because I have 4 times 3. 4 times 3 is 12, and we're talking about hundreds. So how many zeros does 100 have in it? It has 2 zeros. So I have 12 with 2 zeros added to it. 4 times 1 is 4. It's in the tens place. That means I have 1 0 added to it because there's 1 0 in 10. And then I have 6 ones. 6 times 4 is 24. And remember, all together it equals 316 times 4. Now, we can also look at this like a place value chart and bundle our answers. So if you look right now, I have 24 ones. Well, couldn't I bundle, take away 20 ones, and move them over here? So if I take away 20 ones, I'm getting 2 tens, right? So I'm adding 2 more tens, but I'm also losing 20 ones. So my 40 would become a 60, and my 24 would become a 4 because I just took 20 tens away. So if you look at this like it's a place value chart, you have your hundreds, tens, and ones. So we have 316 times 4. So you start with 300 times 4 is 1200. 10 times 4 is 40. And 4 times 6 is 24. And then you add them all together. So 316 times 4. Remember, this is the partial. This right here is partial algorithm. And this one right here is standard. So on standard, remember you start with the ones. You say 4 times 6 is 24, and you have to carry your 2. 4 times 1 is 4, plus 2 is 6. 3 times 4 is 12. Do we get the same answer both times? Yes, we do. Now remember, the whole goal of Engage New York is to show you a variety of methods and then for you to choose which one works the best for you. Now, if you get the wrong answer with the method that you choose, obviously it's not a good method for you. You need to find a method that works for you where you get the right answer every time. Okay, so you're going to try it out. Create an area model for the following problem and then solve using partial or standard algorithm. So pause it and try it out. Okay, I'm going to go ahead and work through this one with you, and your job is to see if you get the same answer that I get. So we start with 5 what? 5,000. And then what do we have here? 4 hundreds. I'm just going to abbreviate. 6 tens and 3 ones. And I'm multiplying by 5. So 5, I'm going to solve this using the partial algorithm way. 5 times 5,000s is 25. How many zeros are there in 1,000? 1, 2, 3. 4 times 5 is 20, and we're in the hundreds place. So how many zeros are in 100? 2. So 20 plus 2 zeros. And then we have 5 times 6 tens. So 5 times 6 is 30, plus our 0 from our 10. And then we have 3 ones. So 5 times 3 is 15. Add it all together. Now, if you use the standard algorithm method, did you still get an area of 27,315? What is this model called? What is this model called? We talked about it a little bit ago. What do we call this model? I kind of gave you a hint a minute ago when I asked you what the area was. Okay, a cafeteria makes 4,408 lunches each day. How many lunches are made Monday through Friday? What are some methods you could use to solve this problem? Use the next slide to solve using your preferred method. Now we have shown you quite a few different ways to multiply during this unit. Which method do you prefer using? So be prepared to share and to explain which method you used. So let's go to the next slide. Whoop, didn't want that. Go to the next slide and go ahead and use this space to solve the problem. Okay, solve the following expressions using, let me change my pen color here, using standard algorithm, partial products, and area model. So let's go ahead and start with this one, area model. Remember, we have our hundreds, tens, ones. Let's look at it like a place value chart. What number is in the hundreds place in 425? We have 4 hundreds, right? What number's in our tens? 2 tens, which is the same as 20. And how many ones? 5 ones. What is our length? Our length is 4. So if you look, we have 4 times what? 4 times 400 plus 4 times, what's the next number? 20 plus 4 times 5. Now let's look at this. Solving using the partial algorithm method. 425 times 4. So 4 times 400 is 1600. 4 times 20 is 80. 4 times 5 is 20. Add them together. So the answer is 1,700. You could do it the standard algorithm way. 4 times 5 is 20, carry your 2. 4 times 2 is 8, plus 2 is 10. 4 times 4 is 16, plus 1 is 17. Did I get the same answer? Yes, I did. Okay, on this next one, what number's in the hundreds? 5, so we have 500. What number's in the tens? 3, so we have 30. And what number's in the ones? 4. And what is our length? 7. So 7, what you would put down here is 7 times 500 plus 30 plus 4. And when it's in parentheses, you always add the parentheses, what's in parentheses first, and then you would multiply. So the same would be down here. 7 times 500 plus 7 times 30 plus 7 times 4. So 534 times 7. What's 7 times 5? 35, and it's in the hundreds. 1, 2 zeros. 7 times 3 is 21. What place is it in? Tens. 7 times 4, 28. $3,738. Let's look at this. 534 times 7. 7 times 4 is 28. 21 plus 2, 23. 7 times 5, 35 plus 2, 37. Did I get the same answer? Yes, I did. Make sure your paper looks like this. You need partial, standard, and then this you'd call the distributive, which you haven't talked about yet. So make sure your area model is filled in on those. Okay. This next one, they're kind of trying to trick you, but there is no number in the tens place, so will you have a 10? If there's no number in the tens place, you won't have a 10. So you'll only have hundreds and ones. Okay. Solve using partial products method. Kayla's school has 258 students. Is that important information? That sure is. Kayla's school has, Janet's school has 3 times. How many students are in Janet's school? So 3 times as much. Solve using partial product method. So we'll start at the front. 3 times 200 is 600. 3 times 50 is 150. 3 times 8 is 24. Add it together. So Janet's school has 774 more students. Okay, on the next one, model with a tape diagram and then solve. Okay, go ahead and solve that. I think the rest you should be able to do on your own. On this one, you're going to do an area model. If you don't remember how to do the area model, this is the distributive, they did say distributive property. So they say solve using the standard algorithm, the area model, the distributive property, or partial products method. So distributive property would be like when we did the model, it would be 7 times 5,000 plus 7 times 100 plus 7 times 30 plus 7 times 1. Okay, or you could solve using the area model, just whatever is your preferred method.